Station, this is Houston. Are you ready for the event?
Houston, we are ready for the event.
European Space Agency, this is Mission Control, Houston. Please call station for a voice check.
Station, this is David Honest with ESA. How do you hear me?
Hey David, this is Station. We hear you loud and clear.
Hello Thomas, good afternoon. You are now connected with ESRO France, Estonia and Austria. I will hand over to you for some opening remarks and then we'll open the floor to questions.
Yeah, I'm glad to be here with you guys today. It's always a pleasure to welcome students and teachers and educational efforts on board the space station. As you can see, in the Columbus European Laboratory, and I'm ready for your questions.
Okay, thank you. So we will begin with our first two questions from ESRO France. France, please go ahead.
Angélique Caudel from ESRO France. I have a question from Bartholdi High School in Colmar, and the student of Mr. Patalano, which is a biology teacher. The question is, could you please talk about research done in space by ESA involving plants and recycling?
Yeah, it's a great question. As you know, we don't have a closed loop system here. We need to be supplied from the Earth once in a while with water and oxygen and things that are necessary for us to live. But we're trying to close the loop as much as possible. There's a few experiments run by ESA. There's one on the ground that's called MELISA, which is a long acronym that pretty much means that we're trying to close the loop and have food, water, and O2 production in a closed loop system, self-sustainable. On board the space station, there's been one experiment that was called Artemis Arthrospira, and basically what we did was we took an algae that's called spirulina, brought it up to the space station, and tried to see how it could absorb CO2 and produce O2. So that would help us tremendously, and maybe hopefully in future life support systems will rely more and more on plants to produce our oxygen and scrub the atmosphere from more carbon dioxide.
Thank you. Very interesting, Thomas. Now I have a question from Joliot-Curie Primary School in Saclay, near Paris, and the pupil of Mr. Tesser. The question is constructing a moon based by 3D printing buildings using moon rock dust, the regolith, still considered a possibility instead of bringing materials from Earth?
Yeah, absolutely. It's very much a possibility. As you can imagine, it doesn't come in cheap to send all the material we need on the moon to construct a lunar base and do our exploration program on the surface of the moon, which we'll do in a few years. So using in situ materials are a very promising way to approach those problems. One of them is regolith. Like you say, it's a fine, powdery, loose, kind of dusty material, gray, that's omnipresent everywhere on the surface of the moon, and it can actually be compressed. It can be heated. You can pretty much build bricks made out of regolith, and you could build pretty much anything you wanted out of those bricks. It can also be turned into a cement-like mixture, which can be extruded from a 3D printer, and you could build more complex shapes. And that's gonna be what we need to build a habitat, to build modules, and to build our equipment on the surface of the moon. So yeah, it's very much a possibility, and it's being studied by ESA as we speak.
Thank you, Thomas. Now we will switch to Estonia. Estonia, please go ahead with your first two questions.
Thank you. Hello, Thomas. My name is Ingrid Rõigas, and I am a physics teacher at Viimsi High School. My first question is, how was the preparation for the Alpha mission different to the preparation for your previous mission Proxima in 2016? What new skills did you have to acquire?
It's a great question, and I think some of the things were the same. The station hasn't changed a lot. It has changed, but not too much. So some of the stuff I didn't have to redo. The spacewalk training was the same. Things like this. Some things were different as far as really technical differences. I had to train on the Crew Dragon, which was my means of accessing the station this time, not the Russian Soyuz like last time. So it was a lot of technical lessons, a lot of time in the simulator, getting used to the suits and getting used to the rescue scenarios and all the failure that could possibly happen. So that took me a lot of time. Obviously getting familiarized with our science program, which is different this time. Every single mission has new scientific experiments that you need to be trained for. I think overall the big difference might have been psychological this time. Maybe I didn't try to absorb all the knowledge. I knew that some things I was not going to be needing because I can rely on the teams on the ground to provide that information if I need it. So I kind of focused more, I organized myself a little bit more, and maybe I was more efficient, but I think it happens all the time when you do something for the second time. It's not specific to space. You tend to be more efficient the second time.
Okay, thank you, Thomas. I am Jonas. I'm a technology teacher, and I'd actually like to ask you what has been the coolest or most frightening experience that you had during your astronaut training?
Most frightening experience. I mean, thankfully, we trained a lot in the sim so that we don't have to get into a frightening experience of any kind on orbit. So we've had a few false fire alarms in the middle of the night. So you wake up in the middle of the night, the big red light is going off, and the sirens are going off, and the warnings are going off. So it doesn't happen very often, but it happened to us. I mean, thankfully, it was a false alarm. We didn't have really anything major. We had a couple, situations during EVA when you had to pay a little bit more attention, but thankfully, I think the most frightening situations were in training, and it's not even really frightening, but you put yourself in those situations where you have to react, where you have to adapt. We've done some caving training on the ground with ESA. We've done some survival training. We've got some underwater training. So this is I wouldn't call it frightening, but I would call it, certainly it requests that you, demands that you adjust your focus, that you're sharp, and that's why we do those trainings, so that when the time comes on orbit, when you have to use those skills, you're ready.
Okay, and now we will switch back to Austria. Austria, please go ahead with your first two questions.
Hi, my name is Joachim Eichinger. I teach mechanical engineering at the HTL Wels, and my first question is, does looking down on Earth from the ISS change your attitude towards sustainability? And looking at our planet, what did going to space change about your perceptions about Earth?
Yeah, it's a great question. I think looking at the planet from the space station, all the astronauts have the same reaction. It's very human. When you're on the planet, you know that you have to take care of it. You know that it's not infinite. You know that the resources are finite. The energy that we have is not unlimited. But it's just a knowledge that you have with your brain. When you take a step back and you put yourself in low Earth orbit and you look at the planet, you can actually see it with your own eyes, with your own perception. It puts those global problems at your individual scale. And then you feel that something needs to be done. So really, what it sounds like it's obvious, but what strikes lots of astronauts is how fragile the planet is, how it's small, how it's tiny, how it's finite, and how there's really nothing around it. I mean, it's the deep blackness of space. There's no life as far as we know. So really taking that step back, I think, changes your perception. It doesn't change the facts. We know the facts, but it changes your perception, and then it makes you want to do more for the environment when you come back.
Hello. My name is Josef Eder. I am a physics teacher in Borgstraßwalchen, and this is our first question. What happens if something breaks? Could astronauts repair most things on their own, for example, by using 3D printing?
It's a great question, and things break once in a while. I mean, it's like everything. Those are very complex systems, as you can see around me. So there's a lot of engineering, a lot of effort are being put into the systems on the ground. But obviously, it happens once in a while that they break. We do really two types of maintenance. We do preventive maintenance. We try to prevent anything from breaking. So we replace some spare parts before they hit their service life. We maintain, we clean, we inspect a lot of equipment. That takes us some time during our work days, during our weeks on the ISS. We also do corrective maintenance with the help, again, of the experts on the ground. They know the systems much better than we do. They know the equipments much better than we do, and they guide us to do what needs to be done to repair the systems when they break. Actually, it just so happened this week that we're trying to fix our second new toilet that for some reason refuses to work, and we've been spending a lot of time, and the ground teams have been spending a lot of time trying to figure out, trying to MacGyver our new toilet. So it happens regularly. As far as 3D printing, we just last week printed a spare part from the 3D printer that's right next to me here in Columbus, and we installed it on our Bryant processor assembly. The old part is not really of the dimension needed, so we printed a new one and we've installed it. So it happens once in a while that we use 3D printing to cover our needs as far as maintenance.
Wow. Cool. Okay, so we will now switch back to France for one question. France, please go ahead.
Oui, bonjour Thomas. I am Lionel Claire, physics teacher at Tronec College, a secondary school in Vielmeer-sur-Agout. Our question is, how is water recycled on board the ISS?
Yeah, it's a great question. We try, obviously, we can't rely on being resupplied in water all the time. So we recycle a very high percentage of our water. All the perspiration is collected and urine is treated. We have actually 2 racks. Racks are those big elements that you see around me. One is treating urine, and it's pretty much being cleaned, being centrifuged. We try to remove, being filtered, try to remove all the impurities, and then that water is being fed into our water processing rack, which is also treating our perspiration water that's collected all over our station. And really what it does is it filters the water a lot, try to remove all the impurities once again, and then it boils it to really high temperature, and then it condenses it back into its liquid form. After that, it passes through a series of sensors to determine whether or not it's good for us to drink. And the current requirements on space station, it's actually 100 times higher. Water has to be 100 times cleaner than what you get from the tap in most cities or town, at least in the US, but I think in Europe it's pretty much same standards. So we drink very, very clean water, and with our installations that we have on orbit, we managed to recycle 90% of our water, so we have minimal resupply from the ground. And again, all that technology can also be applied to the same systems, same problem on Earth, and try to improve life sometimes in areas where you need cleaner water.
Thank you, Thomas. Okay, so we'll now switch back to Ezra Estonia for one question. Estonia, please go ahead.
Thank you. Hello, Thomas. Here is Ingrid Regas again. My second question is, your last mission on the ISS was Proxima in 2016. What are the most significant changes in the ISS compared to 5 years ago?
It's a great question. There's so one of the changes that I've already mentioned is that now there's 2 ways of access, 2 means of access to the ISS. The Soyuz is still doing great. That's what I call the kind of the East Road, and then there's the West Road launching from Florida, Cape Canaveral, and for now it's the Crew Dragon from SpaceX. So that's pretty much a big change. Not for the 6 months that you spend on orbit, but for the ride up and down. There's been a lot of changes inside the ISS. Some systems have been improved. Some science payloads have been flown up. Like I said before, the science changes all the time. But there hasn't been a new module. In fact, the newest module, which is Russian module, is called NMLM. It should arrive soon in July. So we're very excited to add a new room to our house, to our space house. On the outside of the ISS, one of the big changes that's actually ongoing is we're trying to upgrade the solar arrays, and we might have to go outside the door and do a couple spacewalks to install new solar arrays to augment the power system on board the ISS. As far as ESA, we now have a new exposed platform just right there outside of Columbus. On the other side of that wall, you can't see it, but there's a platform that's called Bartolomeo, and it enables the European science community in general to have access to also the outside of the space station. So now you can do research inside, but you can also have payloads on the outside. So the space station is an ongoing, it's a constantly changing work environment, and it's going to keep being like that until it's decommissioned, and hopefully in a very long time.
Okay, and now we'll go back to Austria for one question. Austria, please go ahead.
Hi, it's Joachim again. Can you talk about future plans of alternative ways to travel and live in space?
Yeah, future plans for traveling in space. I think they're happening as we speak. Like I often said that it's now is the golden age of space travel. We have a lot of different vehicles flying. We have a lot of different ways to get to space. It's never been the case. I mean, there's so many now opportunities to go to space, and so many different companies and agencies and countries being involved in space exploration. I think what you see on one hand is try to open space travel to a more diverse population, not only professional astronauts, but also some other types of careers and backgrounds. And this is happening. This is not necessarily bad. I mean, we don't have anything against it. If anything that can give momentum to space exploration, I think is good. And also what's happening is we're trying to do space exploration in a more sustainable way. And we have projects in Europe to build some recoverable first stage vehicle. We will do some first stage landing with Prometheus. It's a very important project for the agency as far as launchers are concerned. Access to space, which is still kind of the big bottleneck to get to space. Also, I think a new way, I don't know if you can call it new way of travel, but maybe new destination is going to be further and deeper into space. We've been exploring, we've been doing science in low Earth orbit for a long time now. Now it's time to take a step a little bit further and go forward to the moon with a more permanent presence. And this is what the Artemis program is trying to achieve, and this is what all the agencies are committed to. And so hopefully in the next few years, we'll see human mission going to the moon, and hopefully then in the years after, to the surface, building a more permanent presence, and then on to Mars. So that's our dream, that's the path, that's the goal, and I'm excited to see it happen in the next few years.
Thank you very much, Thomas. I've just heard that we have time for one more question from ESRO France. France, please go ahead.
Hi, Thomas. Nice to meet you. I am Sandrine Guerrard. I am a biology teacher in Alexis Monteil High School in Rodez. The question of my student, and particularly Clément, is what happens to waste in the ISS, and what can and cannot be recycled in ISS? And finally, where does the organic waste from the ISS go? Thank you.
Sorry, I didn't really hear the question. I'm sorry.
I'll just repeat it for you, Thomas. What happens to waste on the ISS? What can and cannot be recycled? And where does the organic waste go?
Oh, right. Thanks. Yeah, sorry for that. We try to recycle as much as we can on the ISS, but obviously human solid waste cannot really be recycled. And there's also a lot of other types of waste, like food waste, that we're unfortunately producing. We're trying to limit it in the first place, trying to create as little waste as possible. And whatever we cannot treat, whatever we cannot proceed, then we pack it in a cargo vehicle. Those cargo vehicles bring up all the supplies that we need, and then on the way down, we pack them with our trash pretty much. And then once they leave the ISS and they're deorbited, they re-enter the atmosphere in a destructive re-entry. So they're being burnt up, they vaporize, and they get us rid of all our trash. So that's the concept that we have right now. So next time you see a shooting star, well, think it could maybe be astronaut trash leaving the ISS.
Okay, thanks very much, Thomas. I'll give you a quick chance to say goodbye to the 3 sites, France, Estonia, and Austria.
Yeah, absolutely. And thanks again. All the great questions, very much on point. So it was a pleasure to have you guys on board the ISS today. Thanks to everyone who was involved in the preparation of this event. Like I said, it's always exciting to share the adventure because we're isolated, we're confined to the ISS, but those events give us also for us a chance to open up and try to reach out to the people. I know there's a national selection ongoing. I don't know if you guys are thinking about it or if you're talking about it, but I think it's an exciting opportunity. I hope we'll see many applicants, and I'm excited to follow this adventure too for the new generation. So thanks for everyone for joining today, and maybe see you in a few years on board the ISS.
Station, this is Houston ACR. That concludes the event.
Thank you to all participants from ESA. Station, we are now resuming operational audio communications.